Welcome everybody. I saw this question on the social media, so I thought I can shed some light on this solution. Now we have this interesting question. We have a semicircle, so I'm going to draw the semicircle. So it's a semicircle there. Shaded red triangle. Now I'm going to take this point as a sum P. We are asked to find the area of APO. There are many ways to solve this question, but the most efficient method I'm going to be showing you here. So this would be considered probably the real technique. Of course, there are many methods, okay? But the point here is to get the efficiency. That is the objective. Now for this question, we are just given one information, which is 2. So OP is equal to 2 units. This is given. And we are expected to find the area of this red region. Now what I'm going to do is, from the point P, I am going to be connecting or dropping a line or extending that line from the point of contact to B. Okay, fair enough. Now we make the following observation. We observe that OPB are on the circumference of the semicircle, okay? Now, which is part of a circle. So OPB, they are all actually on the circle. Now if you were to go and complete this circle, OPB will be on the circle. So that is the contention here. So by Thales theorem, if OPB are on the circle and if OB forms the diameter, then angle at B should be equal to 90 degrees. So this is the all important Thales theorem. So this angle is 90. Okay. Now if I were to take this angle as, say, some alpha, okay, and this angle as some beta, from the law of triangles, 90 positive alpha positive beta should be equal to 180, which means alpha positive beta is equal to 180 minus 90, which means alpha positive beta is 90 degrees. Fair enough. Now if you observe here, okay, there is also a 90 degree. Now I'm going to come to that 90 degree a little bit later. Now foremost, let us consider triangle BPO. By the law of trig ratios, what do we see here? If I were to take alpha, the angle opposite to alpha, or I would say the side opposite to alpha is opposite side, right? This is my hypotenuse side. This side is my hypotenuse side. So I'm going to use sine alpha. Sine alpha is opposite side by hypotenuse side. My opposite side is 2 units. The hypotenuse side is OB. So therefore we have sine alpha is 2 over OB. Okay, fair enough. Let that be there. Excuse me. Okay, now you consider this quarter circle. Okay, consider quarter circle. So what is the quarter circle? Quarter circle is OAB. So clearly angle at O is 90 degree, is it not? This entire angle is going to be 90 degree, right? But we know alpha plus beta is equal to 90 degrees. So that means this angle should be equal to alpha, right? So now you consider triangle PAO with this being alpha, this being equal to 2 units. Okay, so this is what is required. So area of POA is nothing but half times this side. Now we have to use this side, which is OP. Okay, so let me mention this point as okay, it's already been mentioned. P is there. So OP times OA, right, times sine of alpha, right? We can use the area formula, is it not? Okay, moving on. But OP is given to us. What is OP? OP is 2 units. So 1 over 2 times 2 times OA. What is sine alpha? Sine alpha is 2 times OB. Okay, now we cancel the 2's. This is going to be 2 times OA over OB. Fair enough. Now go back to the figure. What is OB? OB is the radii of the quarter circle. And what is OA? OA is also a radii. If OA is equal to R, say capital R, let me have this as capital R. Okay, this means OB will also be equal to capital R, right? Where R is the radii of the quarter circle. Okay, so what happens here? This is R, they get cancelled, giving us what? 2. So what does this imply? This implies the area of the red circle is 2 square units. So that's a solution. Okay, so I have done this solution in a detailed fashion. Of course, in 5 seconds we can get the idea, but to apply the idea and to get the result, we definitely require time. Thank you everybody. Please like, share and subscribe.